Please subscribe my channel and watch my lectures online, and please do not download my videos. Okay, in the continuation of the course, I want to start with a new definition about some special kind of interpolating polynomials. Let me start by a definition. Let f be a function that is in fact that is differentiable enough on interval a and b. Now let x0, x1 to xn is a set of distinct points in A and B. Now, we want to find a polynomial, so let me write something like this. Let P of x be a polynomial such that the kth derivative of p at xi is equal to the kth derivative of f, and at xi for k equal to 0 to mi minus 1 and I equal to 0, 1 to n. In fact, p of x is a polynomial that the value of kth derivative of p at nodal point x0, x1 to xn is equal to the kth derivative of f at nodal point xi. Okay, this kind of polynomial is called osculating polynomial of f. So let me write this kind of polynomial calls osculating polynomials that approximate f of x. Usually we consider mi equal to 2. In this special case, we call p of x a Hermit polynomial. So let me write a note here. If mi equal to 2, then p of x is called Hermit, interpolating polynomial. Okay, but first we want to consider the general case, and then we say some theorem about computing the Hermit polynomial. Let me give you some idea about Hermit interpolating polynomial idea. Let me tell something. We can show the Hermit interpolating polynomial the idea of Hermit interpolation as below. Let we have, for example, some nodal points. Okay, let me consider a line like this. Here, and let me consider some point on it. For example, here you consider x0, here consider x1, here consider x2, and continue in the same way until we arrive to xn as n plus 1 nodal points. Okay, we want to find and also we know the value of f and the derivative of f up to the kth derivative of f at these nodal points. In fact, I know f0 and f prime 0 and f kth derivative of f at 0. In fact, f0 is f of x0, f prime 0 is f prime of x0, and fk0 is fk 0 fk at x0. And also at this point, let me call it, for example, f1, f prime 1, and fk1. This is f at x1, f prime at x1, and fk at x1. Okay? And also here, for example, let me call it f2, f prime 2, and fk2. And we continue in the same manner until here I get fn, f prime n, and fk n. Okay? Now, if there exists such polynomial that in fact be equal to f0, f prime of 0, and fk of 0 at x0, okay, some in fact equality should happen. Okay, so let me write something. If p of x be a Hermit interpolating polynomial, we should have, okay, we should have this equality. The first one, we should have p at xi should be equal to fi for I equal to 0, 1, 2, n. Also, we should have p prime at xi should be f prime I, and also this should be true for 0, 1, 2, n. Okay, and also we should continue up to p kth derivative at xi should be equal to the kth derivative of f at xi. Okay, and also this should be true for 1 to n. Okay, from the first equality, in fact, we have n plus 1 constraint. Okay, and from the second one also we have n plus 1 constraint, and also for the last one we have n plus 1 constraint. Okay, so finally, if you consider all of these constraints, you have for example I equal to 0, 1, 2 and 2k. So in fact you have k plus 1 times n plus 1 constraint. Okay, so totally you have k plus 1 times n plus 1 constraint. Okay, all of these constraints should be approved, and if we do some computation, we can find in fact a system of equations with some unknown and some equation, and we can solve the system of equation, the linear system of equation, and find the coefficients of the Hermit polynomial. Okay, so now let me do some more computation. Let me first write. So we need a polynomial of degree k plus 1 times n plus 1 minus 1. Okay, so we can consider p of x as, we define p of x to form sum a equal to 0 to m ai x to power of I, where m is equal to k plus 1 times n plus 1 minus 1. Let me call this equation number 1. Okay, now if we want to find the Hermit polynomial, we have to do some steps. If we want to find Hermit polynomial, we have to do first, we have to in fact construct a polynomial like 1. So the first step, construct a polynomial like 1. Okay, then number 2, construct the constraint of the Hermit. Okay, and finally try to find the coefficient of AI. Try to find the coefficient AI. Okay, the coefficient should be for 0, I for 0, 1, 2, m. This is all we have to do. Before I try to prove some theorem for you, let me give you an example. Okay, let two points x0 and x1 are given. Okay, it means that n equal to 1. N equal to 1. Okay, and let k be equal to 1. What's k? K is the order of derivative that we introduced it here. Okay, so here in fact I have x0 and x1, and also I have f0 and f prime 0, f1 and f prime 1, just for constraint we have. Okay, now, and let k equal to 1, and let we have the following table. Okay, let me consider something like this. Let's consider x0, x1. x0 is, for example, 0, and x1 be equal to 1. Okay, and also let we have f0, f prime 0, f1 and f prime 1. Okay, so we know that in fact f0 is f of f0, f prime 0 is f prime of 0, f1 is f1, and f prime 1 is f prime 1. Okay, so we know that the degree of the Hermit interpolating polynomial is k plus 1 times n plus 1 minus 1. Okay, we know that the degree of Hermit polynomial is k plus 1 times n plus 1 minus 1. Okay, but we told you k is equal to 1 and also n is equal to 1. So here we get 2 times 2 minus 1. Okay, so this means that m is 2 times 2 minus 1, and it will be 3. So we have in fact a polynomial of degree 3. Okay, now we consider the Hermit polynomial p of x to form a0 plus a1x plus a2x squared plus a3x cubed. Okay, and we apply the constraint. What were the constraint? The constraint was p of 0 should be f of 0. P prime of 0 should be f prime of 0. P of 1 should be f of 1, and p prime at 1 is f of 1. Okay, and this gives, here put 0 instead of x, so we get a0 should be equal to f0, and this gives, in fact, this one gives a0 equal to f0. Now consider p prime of x. Let me write p prime of x here. We get a1 plus 2a2x plus 3a3x squared. Okay, so consider p of 0 here and put p prime of 0. P prime of 0, put 0 here. P prime of 0 should be a1. Okay, so a1 should be equal to f prime of 0. It was f prime 0. And p1, put 1 instead of x here. We get a0 plus a1 plus a2 plus a3 is equal to f1, and also p prime 1, a1 plus 2 a2 plus 3 a3 equal to f prime 1. Okay, these four equations give us a system of equation. We can write the system of equation to this form. Let me write the system of equation. Let me in fact move this line by this line, so I will get something like this. A0 should be 1 0 0 0, and if I consider this row here, I will get 1 1 1 1, and also I should consider this one 0 1 0 0, and also this one 0 1 2 3. This is the coefficients, and I have a vector a0, a1, a2, a3, and this should be equal to f0, f1, f2, f3. Okay, now if you solve this equation, this system of equation, you will get a0 equal to f0, a1 equal to f prime 0, a2 equal to 3f1 minus 3f0 minus f prime. Sorry, I don't know what happened in my computer, and I lost all of my in fact handwritten, but no problem. If you have written my notes, you can continue exactly from here, don't worry. And let me write the final system here. 1 1 1 1 0 1 0 0 0 1 2 0, and a0 a1 a2 a3 equal to f0 f prime 0 f. No, let me fix it. Here it should be f1 f prime 0 f prime 1, and I told you this gives a0 equal to f0, a1 equal to f prime a2, I guess. A2 equal to f prime 0, right? A1 equal to 3f. Maybe something wrong. Yeah, here's something wrong. If you refer to the previous notes, you will get a1 should be equal to f prime 0. Okay, and if you compute the other coefficients, a2 is equal to f3f1 minus 3f0 minus f prime 1 minus 2f prime 0, and finally a3 should be equal to 2f1 plus 2f0 plus f prime 0 plus f prime 1. It doesn't matter, but let me do some special values for f0. For example, 1, f prime 0 let be equal to minus 1, f1 be equal to 3, and f prime 1 be equal to 2. In this case, a1 should be 1, a2 should be minus 1, a0 should be 1, a1 should be minus 2, a2 should be 6, and a3 should be minus 3. So we can find p of x into form 1 minus x plus 6 squared minus 3x cubed. Okay, if you want to check that p of x is correct or not, you have to compute, for example, p0. p0 is 1, okay, and 1 is equal to f0, so it works. Yeah, and now let me compute p1. Put 1 here, 1 minus 1, 0, 6 minus 3 is 3, so f1. This is 3 and this is equal to f1. Now compute p prime at 0. P prime here, if you compute p prime of x, it's minus 1 plus 12x minus 9x squared. Okay, put 0 here, it will be minus 1. And f prime 0 is minus 1. And this is f prime 0. So this one also satisfied and it works. And finally compute p prime 1. It will be 12 minus 10. It will be 2. And this is exactly f prime 1. So all constraint satisfied, and in fact I have find the Hermit polynomial easily. This is the start of the Hermit polynomial, and I will continue in the next lecture by some theorem and some existence and uniqueness of Hermit polynomial. Please follow my channel, subscribe my channel, watch online, and please do not download my lectures. Thank you.